Okay. So and means intersect. What does or mean? Or means union. Okay, and means intersect, or means union. So here's an example. X is greater than 3 or x is greater than or equal to 5. What does it mean? Well, you have x greater than 3 and you have x greater than or equal to 5. And what it means is x is in the solution set if either of the two conditions hold or both. When we say or in math, we mean either or both. There's something called an exclusive or, which we write as XOR, which means either one but not both. And in English, sometimes when we say or, we mean the exclusionary or, but that's not what we mean in math. So if X is in either of these sets, then it's in the solution set. Okay, so if you look at this, so it has to include all of these points, and it has to include all these points. So what you're doing is you're just taking the sets or the intervals, and you're just mushing them together. Right? And would be intersect, you would take where they overlap, which would be from here up, 5 up. Or you're just mushing it all together, just taking all the points. So you go from 3 to infinity. So this simplifies to 3 to infinity. So I graph the solution on the number line. So if you do it separately, 3 to infinity is this green one. I colored them for you. That's this one, first one. Union, 5 to infinity. You have to graph these. Graph these like I did here. And then you can see that this simplifies. The union, you scrunch them together and you just get 3 to infinity. This one doesn't actually contribute any additional points, right? So that simplifies. Unions, intersections always simplify. Unions usually simplify, or often simplify, but not always. If the unions intersect at all, they simplify. So this is interval notation, of course. And this is algebraic notation. X is bigger than 3. X is greater than 3. Yeah, they could ask for either form, so pay attention. Or they could ask for the graph, but usually people won't mess that up because they'll have a place to graph it. Now let's do and with the exact same ones. See, this is exactly the same, right? Except there's an and instead of an or between them. Notice I always underline these because they're important and people have a tendency to ignore them. So and means I'm going to intersect. So I'm going to graph x greater than 3 and x greater than or equal to 5. And then I intersect them, see where they overlap. And you can see, I hope, that that's from 5 up. So if I intersect those two, I get from 5 to infinity. Now the reason these two are working out kind of weird like this, where you get one of the two intervals for your answer, is because they're both going the same direction. Right? It's different if they both go different directions. So that's just algebraic notation, x greater than or equal to 5. Okay, here's another example. 2x less than x plus 1 less than 5. Okay, compound inequalities where the three things put together like this. So 2x less than x plus 1, x plus 1 less than 5. It also says 2x is less than 5. When you have those three inequalities like that stuck together like this in this kind of compound inequality we saw first, if there's a variable in 2 or 3 places of the 3 sides, in quotes, there's 2 of them, right? You can't solve this the simple way we did before where you just subtract 1 from all 3 sides, and then da-da-da-da-da. Because you have 2 different x's, and you have to get 1. So say I decided to subtract the 2x to get it over here, or subtract the x to get rid of the x here. Well, then I'd end up at x here, but I also have a minus x here, so I still have an x in 2 places. And this is what happens here: is if you just keep subtracting it, you always end up with x in 2 places. You can never get down to 1 place. So the trick to doing these is you split them into separate inequalities, and you put an and. These things where they're combined into a single one of these inequalities with the 2 inequality signs are always and. They're never or problems. They're always and. So I write down and right there to remember the solutions I'm going to intersect. So you solve these 2 inequalities separately. And you see I got x less than 1 and x less than 4. Again, my arrows are pointing the same direction again. That's just coincidence. And I'm supposed to intersect them, so it'll be x less than 1. Right? Algebraic notation. So this is just an example of a check. You test the endpoints of your solution. So on this one, I only have this endpoint. And then you check in between. So that would be like over here, check a number and see if it satisfies the inequality. Okay. So the endpoint here was 1. Right, that's my endpoint 1. So I put 1 in here. And when I put 1 in, I should get one of the 2 inequalities being equal. So when I put 1 in, I get 2 times 1 equals 1 plus 1. So those are equal. Now, you might say, but they're supposed to be less than. Yes, that's true, but it's also an open, it's a parenthesis. So it's not supposed to actually work. It's supposed to be almost work, right? So you get 2 equals 2, and so that checks. Okay. And then try a point. I tried 4. Why did I try 4? That's the other endpoint here. Right? I'm checking to see if I did this right. So I check this endpoint, 4. And I see in here, 4 plus 1 is 5. That's not less than 5. It doesn't matter that 5 is bigger than, well, it's not even that. That's not even true. If either of these inequalities doesn't work, then it doesn't work. Okay, and then I want to try, so I tried this endpoint, I tried both endpoints, 1 and 4, of the originals. And the 1 works and the 4 doesn't, so that's a good sign. And then I would try a number over here, like maybe 0. And that should work, right? So 0, you get a 1 less than 5, that's true. And you get a 0 here, 1 bigger than 0, that's true too. See, so it looks like I shaded the right region. You might want to check between. So that's the region that works. Then you would try, we'll do this later too with second degree polynomials. You might want to try this region and try this region. So if you look at these 2 points, they divide the line into 1, 2, 3 regions. So I check the points themselves. And then I checked the points in between. So I checked this one, it worked. Great, that's solid. I checked in here. What did I use? 2. So you put 2 in, you get 4 less than 2 plus 3 is 3. 4 less than 3. Nope, that's false. So that shouldn't be in the solution, which it's not, right? The red one's the solution. And then I could try 5. 5 plus 1 less than 5, that's false. So this one over here is not shaded either. So it's got to be this one. So that's just checking my work. I wrote it out here for you. Okay. But that's the idea. That's what I'm doing. Okay. So that's that.